Okay, so number two, the client manager for this one is Dr. Colin Ragish. I'll just speak briefly about Central Marin Sanitation. You know, we work globally and we work with large utilities that manage lots of wastewater treatment facilities. And we work, the US is interesting because, you know, it's a lot smaller. You have small communities managing their own water, wastewater infrastructure. California, however, in general, tends to have this culture of innovation that, you know, it manifests itself across a lot of the utilities in California. Central Marin certainly stands out as a smaller utility that's doing amazing work and people who are just thinking ahead. So when we went to visit CMSA, and they're located just across the Bay Bridge from San Francisco, when we went to visit them first, you know, again, we just presented the technology and they came back to us with, you know what, we have these digesters. We know they're underloaded. We would love, and our goal is to process more organics, work with local industry, receive more organics from them, fog, restaurant waste, and we're going to get that into our digesters and we're going to produce more biogas and we're going to generate more revenue for our utility. So working with people like that who are thinking about revenue generation and not just cost savings, for us is really, really exciting. But the challenge is, you know, we can just operate our digester normally, and that's fine. But, you know, if we can work with local industry, if we can receive additional organics, if we can generate more biogas, if we can produce more electricity with CHP, then that's a massive bonus for us. The challenge is the risk, if we do that, of potentially causing a system to go sour or, you know, the system not performing very well and not having downtime in our digester. That would defeat the whole purpose of things. So to get there, to stop that from being an issue, we need better data. We need sensors that are going to tell us in real time when our system is stable, and more importantly, notify us early when our system is going to go into a state of imbalance or potentially move toward that position. So that was the problem statement they posed to us. They have a fantastic pilot scale system set up at the facility, 2 duplicate reactors, and I'm going to hand over to Colin and he can talk about it.
So hopping right into how we're installed into the system, we're installed on recirculation lines, 1 on each of the reactors. And installation was quite quick and easy. Once they had the T's installed, we're really looking at 2 to 3 hours to complete this installation. And they've had quite low maintenance here. So we ask every once in a while, so we're looking every 3 months to visually inspect it. Or if we see really unusual activity here at the site, we'll ask them to pull the sensor out, take a look, and just to verify everything's okay. They have had to clean the sensors a couple times, and this was just a heavy coating of fats, oils, and greases. That can happen. Physical obstructions on any sensor are a problem. Hopefully Pat can flip the slide here. There we go. So we'll hop right in the data. What's really awesome at this site is we have 2 systems that are operating in parallel with the intention of them being identical. Now, kind of unique here is we see 6 hours of feeding every day. And if you look at that graph, we see the 2 reactors reacting to this feeding with an increase of activity daily. And then the activity drops off as the feed is consumed. And what's really of interest and of concern at the site is how do we manage feeding of fats, oils, and greases? Trying to use it as a value-added feedstock, but we know it can be challenging. And one of these challenging events was shown on May the 9th. Essentially what happened is they started getting feed into the pilot reactors that was much more concentrated, specifically in solids. The solids were about 5 times greater than the typical feed. And what SENTRY denoted right away the first day is that we saw a change in the pattern of activity, and after that we saw increasing activity. So we know something has happened to the biology, and we had a nice stable reactor, so we know there's something to be concerned about and watch out for. And at the site, they had a few parameters that they would typically use for imbalance. And the first one to flag of imbalance was 3 days after, and that was volatile acids reaching over 200 milligrams per liter. However, SENTRY was telling us that something had changed 3 days before that, really giving an opportunity to do something. And in these 2 reactors, we actually found that the volatile acids peaked above 2,000 milligrams per liter. Unfortunately, that meant when the reactors had to be completely restarted, so cleaned out, we started from scratch. And the other one, it took about a month to nurture it back to typical conditions. So you can see that SENTRY provides a unique opportunity to avoid these kind of failures. And what we've really found throughout working on different anaerobic digesters is that unfortunately, monitoring is quite data and information poor. And it's a result of a lot of the information we need to collect or want to collect requires manual sampling traditionally. And this is both expensive and time consuming. And these parameters are a delay of what's actually happening in these systems. And this really means that we're always behind that 8 ball a little bit, and our operations are quite reactive. So unique SENTRY, and since we're really looking at the fitness of the biology and the biological process, we're able to provide this advanced warning. In this case, it was as much as 3 days. And we believe that this is a substantial opportunity that will allow us to limit negative impacts so you can maintain your biogas production for sale and also to avoid that potential reactor downtime. So when we're looking at something like the size of CMSA, as Pat said, one of these downtime events that could last for a month, you're looking at a cost exceeding $45,000 to $90,000 or even greater. And so now that we've completed some work on the pilot scale, CMSA has great interest to now install in a full-scale reactor. And so we're doing that work right now. And the whole goal is to avoid these downtime expensive events. And as we go forward, hopefully to also increase what they can produce.
Fantastic, Colin. And I'll just add to that as well. I do think there's a growing demand in North America for co-digestion when it comes to, leveraging that additional capacity that municipalities have in their digesters to produce more biogas.